moving forward to the first presentation, I would like to invite John Heller from Ecotope to guide us and enlighten us about advanced water heating specifications. Over to you, John.
Thank you, Vidisha. So Ecotope is a mission-driven company in Seattle, Washington, engineering and research focused on transforming buildings to energy-efficient, carbon-neutral buildings. And we've been working on large multifamily commercial heat pump water heating systems for about 15 years. And once we kind of proved that we could do it in buildings, then we have kind of shifted in the last several years, helping lead the commercial section of the Advanced Water Heating Initiative, trying to develop the tools to make utility programs around these systems possible. And so our vision for where this is going is that these multifamily, large commercial heat pump water heater systems could be standardized plug-and-play systems with a single point of warranty or sale for the entire system, achieving annual average COPs of 3 or better, shifting to using low GWP refrigerants, that they'd be affordable, reliable, redundant, and that load shifting and demand response capabilities would be standardized in these products. Go ahead and to the next slide, Vidisha. So when we talk about these systems, it's what you're seeing on the left there, these large heat pumps with large storage tanks, controls, mixing valve, and it's all of the same parts and pieces that you're familiar with in a residential package system. All those same parts that you think of when you say, okay, heat pump water heater, all are part of the commercial system as well. So we want to think about this not as individual commercial heat pumps, but as heat pump water heating systems. Go ahead to the next slide. And these systems are pretty complicated. There's a lot of parts and pieces that have to work properly together. The design is critical, the sizing is critical, the little balancing valves are critical. And so to be able to make this happen at scale is what we've been working on. Go ahead and move to the next slide. So what we've been trying to do is move the industry from where it's been, which is custom engineered systems where a designer needs to specify the heat pump and then specify some tanks that are appropriate with it, specify a system to take care of the temperature maintenance load, a controls contractor perhaps, and get it to all work together in the field. That is challenging to do at scale and to get it right because there's so many details that have to come together. So what we're trying to do is move towards the right on this slide. Instead of specifying all the parts and pieces from a single contractor, in the middle, what we kind of refer to this as the IKEA approach, where all the parts and pieces are coming from a single distributor, and they're providing design support, a schematic that shows how it all goes together, a single point of warranty. So it's sold more as a system, but to be put together in the field. And then all the way on the right, there's a few manufacturers that are starting to offer fully prepackaged, pre-built systems that were put together in the factory and tested before it even goes out to the site. And so for a utility program, the chances of getting what you think you're paying for increase as you go to the right on this slide. Not saying that it can't be done in custom engineered systems, but it's much more likely, much more standardized as we move to the right on this slide. Go ahead to the next slide. The other thing I want to point out becomes possible with these large systems is the ability to shift load off of peak utility periods. So what you're looking at on this slide, the blue line shows a typical hot water demand load for electric resistance water heating. And by shifting to a central heat pump water heating system, you get what you see in the gray bar there. So you've reduced the peak load by about a factor of 3, and really flattened it out over the day instead of having these big morning peak and afternoon peak. And then with the addition of load shifting controls, you can do, for example, what you see in the yellow line there, and shift the operation of the heat pump out of, for example, that evening peak time completely, and move that operation into the nighttime pre-load up before the morning peak. So the fact that you've got this large amount of thermal storage on site makes this possible with proper controls. Go ahead, the next slide. And I don't expect you to get much out of this slide except seeing that it's pretty critical in these early days of this technology to have data that can be analyzed to be used to optimize the performance of the system when it's being commissioned, and then to track the performance over time. And Ecotope has developed a standardized, simplified data pipeline and data dashboard. This, what you're seeing here, is called EcoDash. And it allows for kind of some standardized calculations, standardized performance metrics to be shown, as well as the raw data that you can zoom in on and see what's happening, and a methodology for maintenance contractors to log events, maintenance events, so that you can go back and see what's happening at any time of the day or over the course of the year. And we're also beginning now to include some standardized fault detection alerts. If we see particular things happening in the data, we can send alerts to a maintenance contractor before it becomes a problem. Go ahead to the next slide. And so the tools that we've developed that really make utility programs possible and simple is starting off with the advanced water heating specification from NEA. And we've added a commercial section to that. And what that does is it provides the minimum design and performance criteria for what we consider a complete central heat pump water heating system. And this really helps to reduce the risk and uncertainty for the designers, because it defines that system and attempts to standardize different system configurations. The product assessment data sheet is the methodology that the manufacturer of the system, whoever's putting the entire system up for sale, can use to upload the performance map for the specific heat pump that's being used, as well as a standardized schematic that shows if you're going to use this heat pump in this design configuration, here's all the parts and pieces that you need, and this shows how it goes together. And then there's a checklist of ways for the manufacturer to demonstrate that they've met all the requirements of the advanced water heating specification. This feeds into a modeling program that's used to predict the average annual performance of that system given a standard multifamily hot water load shape. And that's then used to, in addition to the performance map of the heat pump that shows how that heat pump performs in different climates, we can predict the annual performance of a given heat pump in a given design configuration in a given climate zone, and predict the average annual system COP. And that then is listed on a qualified products list that that then can form the basis for savings calculations for a utility program. Click one more time. And so what that system COP is different than just the equipment COP, which would be the heat pump only. It's different than what you would call the primary plant COP, which would include the impact of the storage tanks. It also includes the COP of whatever system you're using to provide temperature maintenance or to reheat the recirc load. And we're really trying to draw the box around the entire everything that's in the mechanical room, to account for all of the heat that's needed by the building to heat the water up that's coming in and going down the drain, as well as the heat that's required to keep that water hot in the distribution system year round, divided by how much electrical energy did you have to spend to get that over the course of a year. That is the system COP that's listed on the qualified products list, and is really what the utility is interested in, right? Not some theoretical single point test of a given heat pump at a given temperature. It's what's it going to do in my climate over the course of a year. Next slide. So this is what the qualified products list then looks like. If you click again, Vidisha, it'll kind of highlight. So this is showing a given heat pump in a particular design configuration, which is there's several standardized design configurations that these can be put in. And then the middle column there, the market delivery method, goes back to that earlier slide I showed. And this indicates whether or not it's being sold for a custom engineered solution, or it's being sold with all the parts and pieces and the schematic and the design support of a fully specified system, or even if it's being provided as a fully packaged system. So this is kind of a ABC level of market delivery and market support for these products. And that could feed into the way that your utility program treats these different products, and the amount of field verification that might be needed. Like if it was fully prepackaged in a factory, maybe you don't need much field verification because we kind of know how they're going to function in the factory, and there's not very many ways to mess that up. If it's fully specified and sold with a single point of warranty, now you know that one entity is taking warranty responsibility for the whole thing. So again, maybe there's not a lot of field verification that's needed. However, if it's a custom system that's being put together in the field and parts are being collected from different vendors, maybe there's some required measurement and verification, or required commissioning steps, sign-off steps before a utility program might treat those. So this gives a way to bring that market delivery mechanism into program consideration. And then finally, it's showing we've got different tiers of performance, and the anticipated average annual system COP of that product in that configuration. Next slide. And then we've taken a step to build this into a standardized calculator with a grant from the APPA several years ago. So this is kind of the beginnings of what might be used for a utility program, but it takes in standard assumptions about how many people are living in a 1-bedroom, 2-bedroom, 3-bedroom apartment, to build a picture of how much hot water gets used by a particular building, climate zone, rebate rates, everything kind of. There's a place for all of those various inputs that you'd need to come up with an incentive calculation. all based on that qualified products list. Next slide. And so to wrap up what we've kind of learned from 15 years of working on these systems is that a systems approach is really necessary. We can't just look at the heat pump itself because there's a lot of different ways to control it, pipe it, size it. And if you don't kind of have a full system look at this, you really aren't going to know how that's going to function in the field. And those design and sizing details really matter for how well these products perform in the field. So a standardized system approach is critical. And that a more packaged market delivery method is really critical if we're going to take these to scale and be able to treat them like under prescriptive programs. We really need that single point of warranty, single point of responsibility for the entire system. I didn't talk a lot about it, but the commercial heat pump water heaters really can be a load shifting resource, but those controls have to be built in from the start. Not every system is going to be able to deliver that. So this is still, I would say, in the early days of integration with most of the manufacturers. A few of the manufacturers are building this in right now, but this is still developing. And I would say that monitoring is essential at this point, because we're still in early days and we're still learning quite a bit, and the manufacturers are still learning, the installers are still learning, the designers are still learning. And so having that data feedback, such as we're able to provide with the EcoDash dashboard, is pretty important at this point. And just to kind of sum up that NEA's advanced water heating spec and qualified products list really provide a strong basis for program development. I've got my email at the bottom of the screen if anybody wants to follow up with questions, but I think I've taken up the time I had.
Thank you, John. And we do have some questions in the chat. Would you like to address them? We can have a minute for that.
Sure. So in central systems for billing, there's the most common method is to put a submeter on the supply into each apartment. I've seen it done different ways. In the Pacific Northwest, oftentimes they will only meter the cold water going into the apartments, and then they'll assume that if you used 5% of the cold water, you also used 5% of the hot water, and bill you for water and water heating energy based on that individual unit submeter. The calculator is APPAs, and I believe it can be shared. I would say that it probably needs some tweaking for any particular utility. It was developed for Tacoma Public Utilities, so that is shareable. And the accuracy. So the accuracy of EcoSim is exactly what we're in the process of validating right now. We had 2 Department of Energy grants to look at different systems across the country. We were monitoring about a dozen systems on the East Coast, Midwest, California, and Pacific Northwest. All that money has been put on hold. Don't know if it will ever come alive again. So more of that is needed to validate those numbers and to either tweak the modeling or provide feedback to the manufacturers or the advanced water heating spec. But I would say that we have several dozen systems being monitored right now through that EcoDash platform. Some of them are performing better than expected. Some of them are performing worse than expected with things that we've identified as could be fixed in the design or the controls. So it's pretty critical at this point to have that feedback, and I'd like to see a lot more systems be providing data like that so that we can really dial that in. But I would say it's pretty good. It's a pretty good estimate. It's not going to be exact for every apartment because different amounts of water usage, different amounts of temperature maintenance losses, et cetera. But on average, I think it's doing a pretty good job.
Thank you, John. I think that will be all for the questions. But if you have any other questions, feel free to put them in the chat. John, I encourage you to engage in case there are any questions. I will move forward to the next presentation, and I'd like to invite a senior project manager from NBI, who's also my mentor on heat pump water heaters, Joe Wachunas, for a quick rapid fire overview of a small commercial field study. Over to you,
That's
Joe.
great. Thanks, Vidisha. John, maybe before you jet, I'll have you join me for this really rapid fire overview because you're part of this project. I do want to just, John, maybe does just put a fine point on it. We were in conversations with Eversource last week, and Prad, you can come on, but I think a lot of utilities, just to speak to John's presentation, aren't aware that there is a specification for commercial heat pump water heaters, that this advanced water heating specification exists, this qualified products list exists. So we just wanted to make that known to folks to start pointing to this, well thought out qualified products list through your programs. Any other fine point to put on that, John, before we dive into the small commercial?
No, I'll put a link in the chat here.
Yeah, so you can check it out in detail. But we really wanted to get that message across to folks because a lot of utilities aren't aware of this yet. Okay, great. Well, I will be quick. I'm going to set a timer for 2 to 3 minutes because we're setting aside some time in our next utility working group devoted to commercial to do a deeper dive, as we'll be further along in this study. But we just wanted to let folks know that currently the Advanced Water Heating Initiative, New Buildings Institute, Ecotope, we're all engaged in what we're calling a small commercial heat pump water heater field study. As John has said, for the last 15 years, we've been researching some larger commercial systems, especially multifamily, but products have come to market that are filling this niche of small commercial water heating. You can see one in the picture there, the A.O. Smith or Lochinvar CHP 120. It's a unitary system that is providing hot water in a lot of different building types. So we have a field study underway that's funded by several California utilities and other funders, where we're looking at 20 to 30 small commercial heat pump water heaters in different types of buildings. We want a lot of them have been installed, but nobody's monitoring, analyzing how they are working. And so we're going to do that as part of this study, and we want to evaluate how they're performing. What's the installation experience like? What are some of the best practices in running these machines really efficiently? Anything else, John, you'd like to add on what we're looking at?
Well, I'd say that the reason that we're interested in this particular sector is that we've spent a lot of time trying to understand heat pump water heaters in single family homes and have a pretty good handle on that. We've spent a lot of time on this multifamily central heat pump water heater system development that I was just showing you, but we don't have a lot of information about these small commercial buildings, and we're beginning to now that we've got a pretty good handle on the residential sector, starting to try to understand better the commercial sector.
Great, yeah. So we are we're really right now in the field installing monitoring MV equipment, and we are getting our first data, and we're going to share more of that, I think, in our August meeting with y'all. But if you're interested in this, in the learnings from the study, just I'll put my email in the chat. If you are seeing small commercial heat pump water heaters go in your territory, we would love to hear about that. So I'll put my email in the chat, and more to come on this topic in future meetings. So Vidisha, I'll turn that over to you unless there are any questions for our next performance. So there's my timer gone off.
Thank you, Joe and John, for this quick overview. Yes, we are really hoping to have more data and insight in the project in a couple of months, and hopefully in August we will have a presentation on that as well. But I appreciate this quick overview, and since we are talking a lot on commercial and the whole theme is on commercial, I would like to now invite my next presenter on commercial heat pump water heater programs. It's not just about the programs here, but also like what exactly is the challenging part. We came across the advanced water heating specifications. There is some studies going on, but if you really, as a business or a small commercial owner, wants to engage in a utility incentive, what exactly does it look like? So I'd like to welcome GiGi Carroll for this presentation. GiGi, over to you.
Thank you very much. Hello, everybody. I am from JEA. We're our municipal utility that is located in Jacksonville, Florida. We call ourselves the First Coast because we're the first thing you drive into when you're coming south on 95 from Georgia. We could go to the next slide. And I do have a partner that works with me. I handle the commercial rebates, both for water and electric services, and Susan handles the residential program. And I'll share a little bit more about residential later, but right now we're going to focus on commercial. Just to give you an idea, JEA is the 8th largest municipal utility in the country. We're located in the Southeast. To give you a customer count, commercial, we've got around 25,000 customers. Residential, we're just under 500,000 customers, and growing. There's a lot of multifamily and residential construction going on. There is a lot of business coming into our area, particularly because we're a logistics hub. But we do have an extremely large service territory. Bigger than the city of Los Angeles, actually. We do have a commercial rebate program. Heat pump water heaters are part of it. It just started this year. We offer a fixed flat $250 rebate. Our participation has been limited, and we can discuss that more in the chat later with questions. Target commercial applications. We have brought this up with hotels, we've brought it up with hospitals, long-term care facilities, restaurants, anywhere where we think that there's large hot water use, and this could be an application that could save them on their utility bill. Currently right now, in the past, multifamily properties were considered commercial. This year, multifamily properties are now considered residential. That could change in the future. It is a little bit different because the apartments themselves, a lot of them the electric meters are individual. So the residents pay their electric utility bill, which is why it's falling under the residential program. But their water service, sometimes the buildings are master metered or the complex is master metered. And then there's common area buildings. Those common area buildings are on commercial rates. So just the common area, just irrigation. Anything that is not unique to a specific apartment would fall under my rebate program at this time. Next. So fast. You all have rebate programs at your utilities. This is the big categories that our rebates fall into. And there's a link there in case any of you are more interested. We can go to the next slide. We even put pictures of water heaters up there. And on our website, when we list the rebates that are available, we have our heat pump water heaters listed as an electric. incentive. Moving on. These are our water rebates. Again, wet technology. Cooling towers actually has been our biggest target and success for water savings. Ice machines, yeah, there's some. And custom actually recently has been a big success, specifically with how high-tech irrigation has become, but we're not talking about that kind of water. Next. Now, trade allies, we did have a training. So our trade allies support our implementation contractors. You can see ICF is at the bottom of the slide. For our commercial rebate program, ICF is our implementation contractor. We have a trade ally network for our commercial. We also have it with Franklin Energy for our residential. We held a heat pump water heater training at NAFACA, North Florida Air Conditioning Contractor Association. They have a monthly meeting, and we had a presentation about heat pump water heaters to just educate them about what they were, what they are, how it works, how it saves both families and businesses money. And then I had a very interesting conversation. One of the members of NAFACA, he owns a large HVAC family business. He's second generation, approaching retirement, third generation's already in there. And they do a lot of residential and they do a lot of commercial business. And I asked him if they would ever consider at this point installing heat pump water heaters. And he said no. And I asked him why, like what's preventing you? And he explained that it requires plumbing, HVAC, and electrical. Having 2 out of 3 of those he's got in-house. To add the third for what he referred to as a niche lane, he did not see it for his business as worth the investment. That it just wasn't a proven out concept for him yet. There were other contractors in the room that felt the same, and yet there were also others that had been installing them for homes and having great success with it. Our rebate also, the cost of a heat pump water heater is thousands, and we're offering a $250 flat standard rebate. Next. Our residential, just so that I want to paint a complete picture here. Our residential program has been very successful, particularly in more affluent markets. As soon as the availability of actual heat pump water heaters increased, the adoption rate dramatically increased, and you'll see that on the next slide. Franklin Energy is the implementation contractor for our residential electric offerings. Again, we're pushing the heat pump water heaters. Next. And look at that adoption. And I don't have, because this was so focused on commercial, I did not ask for an update on the residential, but we offered a flat $350 on the residential. There are obviously guidelines in order to get the rebate, but look at how steep the number of heat pump water heater installations. And right now we're, I believe we're averaging 30 a month. Next. Franklin is working very closely with its trade ally network with major plumbing and HVAC suppliers and pushing the education and just pushing heat pump water heater information to them so that they can then make the sale at the residential level. Next. And contact information is there. Susan for residential, myself for commercial at JEA. ICF is our business, it's our implementation partner for commercial. Franklin is the implementation partner for our residential programs. I am open to what I'm looking at the questions pop up right now.
Right.
I agree with you, Joe, on your first point. Why the increase in sales?